guys can all watch it later. So I'm recording now. And so what we're going to do for this week is, here's the plan. The first thing we're going to do is one of the other TAs made an exam review, and then someone else made a Kahoot out of it. So we're going to play Kahoot, if you guys know what that is. So you guys are more than welcome to join that. I'll put the pin for it up now. I'll share my screen so you guys can all see it. So yeah, you guys can all join that. And then after we do the Kahoot, there'll be a couple other questions on that exam review of some like programming questions that we'll go through. And then after that, whatever questions you guys have after that, just feel free to ask. And then we'll go over like whatever questions you have at the end. Or if you have anything like at any point, you guys can ask them too. And so yeah, for those of you who don't remember, like there's an exam on Thursday, so that's why we're doing the exam review.
And a couple tweets.
So yeah, for anyone just joining us, go ahead and join the Kahoot game so you can play along. I'll give like 2 more minutes or so, and then we'll start. Nice. I like the name. Hello World. Very good. All right, I think that's everyone here. Is it anyone still want to join who hasn't joined yet? If not, I'll start it. I guess I'm just gonna start because it looks like everyone. All right, it's good luck. Yeah. So 10 answers. All right, nice. Nine, 8, 7, 6, 5, 4, 3, 2. All right. Yeah, bytecode. So nice. I know this is kind of a tough one to remember because it is the beginning of the semester, but like this kind of stuff is just things that like if you memorize or know, or if you know, might be an easier question, something like this, once you know it. But yeah, good job. Yeah, it's bytecode. Java compiler produces bytecode because it takes in, well, we'll go to the next question. I don't remember if it's, actually, I don't think it is. But yeah, it takes in bytecode and spits out machine code. And, oh, well, the bytecode gets translated into machine code and it takes in source code. All right, cool. Good job. All right, next question. Well, I may have spoiled this one, but okay, it's okay. Nice, yeah. It takes in source code. Yeah, the machine code is what like the byte code gets translated into so the machine can understand it. But yeah, source code, nice job. Source code is like what you write, what you type out. Like that little SRC file. SRC is for source because you write source code in it. Ooh, question 3. Awesome. Yeah, that's how you do multi-line comments. The double slash is only for single line comments. Oh, I think someone else joined this meeting. So if you want to join the Kahoot game we're playing, I think you still can. Yeah, this is the game. All right, next question. Nice job, Keller. Yeah, nice. It's 1. Because in the question we had, show me the question. Yeah, that's okay. Cool. Yeah, so like we had a divided by b. This is integer division. So 12 divided by 9 gives us 1. And this one gives us 0 because integer division. And 1 plus 0 is 1. So very good. Okay. You guys did really well. This is a really tough question, so good job. For those who didn't get it, I'll go over it really quickly. So yeah, we have A is 5, B is 2, right? That does not look like an A. I'll erase it and rewrite it. But then this makes A become 25. And then A plus equals B plus plus. So this is a post-increment operator. So it does the increment like at the end. So first it adds B to A, and then it increments B. So we have A becomes A plus B, so that's 27. And then we increment B, so now B is 3. And then we print out A plus plus, so that means we're incrementing A after we print. So we're printing 27, and then A becomes 28. And then here, we increment B before we print. So that's a 4. And then here, I mean, it's all in one line, but yeah. And then we increment A after we print. So we print 28, and then we increment, and then A becomes 29. Okay, hopefully that made sense. If not, you guys can ask, but other than that, I'll go on. Yeah, next question. Oh, I see someone else join, or some other people join, so you guys can join this fun Kahoot game. Pin is here. Oh yeah, so good job. It's 2. Because this is basically just saying like if A is greater than B, then assign B to B. Otherwise, assign it to A. Well, A is greater than B, so we just make B equal to B. So we print 2. Okay. And someone asked if this is similar to how the exam is formatted. Actually, yeah. Like probably a lot of the questions are going to be very much like this. And like someone will make you like trace code and whatever, or be something like this. Like this exam review is going to be similar to the kinds of questions you'll get on an exam. So I think this is like a good idea of how you'll do. Or, I mean, there's more time to study, of course. But yeah. Good job. Thanks. Yeah, so as you can see, there's no break statement, but I think, yeah, that's right. So yeah, 2 mod I, well, 2 mod I is 2 because I is 6, so we just get 2. Because we divide 2 by 6, we get 0 remainder 2. And then there's no break statement, so it just falls through and we print. Okay, but yeah, the 1, 2, 3, 4, that one is good thinking, but unfortunately, like in this case, it like does whatever's in these parentheses first, and that gives us 2 and not 0. That was a tough question. True or false? Oh, yeah, sorry. I guess if you didn't hear me say this earlier, like today's lab is like optional. It's an exam review, and I'm recording it, so like if you can't be here, that's okay. And there's no like quiz or anything. It's just a review today. Yeah, good job. It's false. Because we do the and first, we see, okay, these two are ANDed together. We have true and false, which evaluates to false. And then we have false or false, which means we're going to end up with false. So we don't do this, we do this, and print false. Yeah, there's another exam review with everyone at 3. That's right. Nice. Yeah, good job. Yeah, this one's a tricky question. So the reason why it is 2 is because A is 5 at the beginning, and this evaluates to true because B isn't less than 2, but it is greater than 5, and it's an OR operator. So we do what's over in the if, and we subtract 2 from A. So now A is 3. And then we also do this if, because notice, it's not an else if, it's just an if. So we can do it. And C, we check 7 is greater than 4. Yep. So then we subtract 1 more from A. So now A becomes 2, and we print. Yeah, minus equals. Oh, yeah, I guess. Yeah, I see that. But like, even if it were like, you're right, it does kind of look like equals equals. But even if it were equals equals, I don't think that this expression would work because you can't like A equals 1. That's evaluates to true or false because it's just not just assignment. Oops. Yeah. Cool. Okay. So next question. Oh, right, next. What's the output? Yeah, good job. Unfortunately, I don't know how to give you more time. So I guess that's a challenge. So you only get the minute for all the questions. Sorry. But yeah, for this question, right, it's, while a count is less than 15, we print a count. So we print 1, because the first time through it's 1. If mod 5 is equal to 0, well, 1 mod 5 is 1. So we don't do this. And yeah, I guess this is a lot, but sometimes it's good just if you want to do it quickly, you sometimes have to notice a pattern to it. But Like, it's good to do it slowly like on an exam. So that's okay. Right. So it goes ahead and does that. It prints the 1, and then this is the end of the while loop here. So it keeps going, and then account is 3, and then it checks, or it prints this. So now it prints 3, and then if it mod 3 it's equal to 0, we increment by 1 and then continue. So now account is 4, and we jump back to the top of the loop. So now we print 4. Does everyone kind of see how to do this, I guess? It's going to keep going for a little while, and then eventually it'll stop. And once it hits 5, it breaks. But is everyone able to follow that, kind of? Okay, cool. Awesome. If anyone isn't able to follow it, let me know, and we can go over it some more. I guess that one's tricky because the continuous too. Okay, next question. I don't know, Hayden. I'll have to check on that. That might be right, but I can't remember. I'll check and I'll let you guys know in an email or something. Like, did the instructor say anything about that? I guess. I don't remember. Yeah. What? Okay, so I guess that wasn't it. Yeah, oh, right. So we want to see if we can convert it to decimal. So yeah, good job. It's 115. I guess it's tough to do in only a couple minutes, or in only 1 minute. Oh yeah, this week is just exam review. And what that means is like there's no lab or quiz this week, but like in this week it's optional lab and like no quiz or anything. But I think next week we have discussion. I think, pretty sure. I'll let you guys know in an email if we don't or if we do. Okay, but for this we go 2 to the 0 times 1 plus 2 to the 1 times 1 plus 2 to the 2 times 0. That's 0, plus 2 to the 3 times 0, which is 0, plus 2 to the 4 times 1, plus 2 to the 5 times 1, plus 2 to the 6 times 1. And so what we get is we get 1 plus 2 plus 16 plus 32 plus 64, which is 96 plus 19, which is 115. Okay? Oh, yeah, 0b just indicates that whatever comes after it is in decimal. No, is in binary, sorry. It just indicates that this number is binary. But I can see why that would be confusing, because you might think, oh, hex, but that's why we have the 0b. Like, this 0b, if it starts, the number is just the standard for saying, oh, this is binary. Just like 0x is a standard for saying, like, oh, this is hexadecimal. This indicates that it's binary. This isn't a hexadecimal number, but I can see why that might be a little confusing. Is there one for octal? There is. I can't remember it. Wait. Yeah, no, I can't remember it. Right, the hex letter. Yeah, I guess that's confusing. But if this were hex, it would be much larger, and I don't think the answer would be here because we would have like 16 to the 0 plus 16 to the 1, and so on. But yeah, you're right. Wait, actually, I think octal, if I remember, is actually this, but I'm not 100% sure. Are we allowed to have a calculator during the exam? I can't remember that. Sorry. You can look at the syllabus, and I'm sure your teachers said it. If not, like you have some time, so yeah, it has one built in, but the teacher has to allow it, and so I can't remember if your teacher allowed it or not. But in general, like if you can't use a calculator, just be fast, I guess. No, but oh, okay, yeah. I would check, and if you have to memorize stuff, oh yeah, 16 to the fourth, 56 squared, I think, or something. I don't know. Yeah. So I don't think we'll make you okay. If you don't have a calculator, you won't have to do like anything too bad. So yeah. But now that I think you'd probably get a calculator. I hope so. Wow, someone answered fast. Nice. Yeah. So however you get there is fine. Uh oh, it is? Okay. Then I guess I was wrong with that game, but thanks for letting us know actually. Appreciate that. Cool. I guess you're right. Yeah. Oh yeah, I guess this question, right? So like yeah, with whatever you get, like it usually like we'll let you know. If it's octal, like we'll let you know. You won't ever get anything like unexpected with base 8. With hex and binary, you have to know, I guess, that it's 0x and 0b are the prefixes. But for something like this, like base 8 will probably. Okay, so yeah, 77 to binary, probably the easiest way to do it is we see, okay, we go bit by bit and we just translate each bit into 3 binary bits. Because remember, if we had like something like this, right? And we want to translate into octal from binary, we would get each of the 3 bits, right, at a time. So we can do the same thing in the opposite direction, and we can translate 7 into binary, and that's 1, 1, 1. And then the next 7 into binary, 1, 1, 1. And then whatever comes after is just 0. So we just get this, which is where this comes in. Okay. Sure. Yeah. So that's just off the top of my head. Yeah, 4 plus 2 plus 1. Exactly. Because like 1, 1, 1, we want to translate 7 into 3 binary bits. And that's just 2 to the 0 plus 2 to the 1 plus 2 to the 2. Right. Yeah. But I know like that can be kind of tough. Like you don't have the powers of 2 memorized. So another way you could go about it, like if this is like too much to memorize or something, you could like translate this into like decimal and then a decimal into binary. So like you could do like 77 divided by 8 and you keep going until you get it in decimal. And then you can translate the decimal into binary if you wanted to. Whatever works, as long as you get to the answer. And like once you get there, you can go back and check. Would probably be something good. Like if you're in the exam, like go ahead and like check it, make sure it's actually right. Because like verifying something in base 2 is equal to something in base 8, you just get 3 bits at a time, right? Like those 3 and then those 3. Well, that's my suggestion anyway. Wow, answer streak 5. That's good. Oh no. Oh darn. That's okay. It happens. It's just for fun. Just don't mess up in the exam. Yeah, okay, cool. So, well, this is a tough one. So, all right. Well, okay. Can everyone try and figure out what this is in base 8? I see 79. Does anyone else have an answer? Okay, well, since I don't see any other answers, yeah, Hayden, that's right. It's 79. Because we have 8 times, or 8 to the power 2 times 1 plus 8 to the power 1 times 1 plus 7. And that is, yeah, as you said, 64 plus 8 plus 7, which is 79. And in the other two, so, right, yeah, E is 14. So we have 14 plus 16 by 4, which is 78. And for binary also, we have 78. Well, I mean, even if we wanted to look at it like this is, we can just translate it into into hexadecimal and see that these are the same because it's 4. And this is E because it's 14. And yeah, so 14 and 4. Okay, cool. Does anyone have any other questions about this now? Or does that make sense? All right, I'll go on. And then if it doesn't, I'm like, yeah. Oh, new leader. Oh. Yeah, so good job. A lot of you got that right, which is awesome. But for those of you who didn't, well, actually, what did you guys put? I'm just curious. Yeah, okay, so let's talk about it. So what happened here is like, notice like how we're casting it. So all of them are doubles, so all of them will end in like a decimal point at the end. But because like all 3 of these are doubles. But another thing to notice is that this one does double division because we cast 13 to a double and then divide by 4. So it promotes 4 to a double in order to actually do the operation. So 13 divided by 4 ends up being 3.25. Yep. And then we do this, we don't do the same thing here for the second one. Notice it does integer division, so 19 divided by 3, which is 6, and then cast that to a double, so we get 6.0. And the last one we do 27 divided by 6.0. This because it makes it a double first before it divides, and so it promotes 27 to a double. So it's 27.0 divided by 6.0, basically is what we get, and that is going to be 4.5, and that's what we get the answers. Cool? Okay. All right. Now let's go to the next question. Yeah. Nice. Answer streak of 7. Wow. Okay, nice job. Yeah, everyone seemed to get that right, which is awesome. Some people maybe didn't answer, so I'll just go really quickly. So right, we have world, hello, and then str3 is equal to str2. So that just assigns worlds to str3. And then we also assign world to str2 again, so still world. And then we set str1, so string 1, equal to world again, which is world world. Exactly. Awesome. Okay. Next question. Nice. Yeah. And so that's something that's good to know with enums is like in general, like enum values, whenever you use them, it's pretty much only ever going to print out like whatever value is here. So like if we have level.second, like it's usually if there's something dot like something, I don't know, if it's dot hello or something, when you print it out, it's going to end up printing out hello. That's kind of just, yeah, how enums work. It's just an identifier almost. Yeah, the choices here were like really obvious. These questions, they're a little bit harder, maybe could have been tricky in a way. So I'm not sure why they were so easy. I'm not sure question on the exam. Like, I don't mean like they're super easy. I just mean like only one answer made sense. So, but you guys got them right, which is still good. Seems like we're only getting nine answers for a lot of questions. Everyone's still playing? If not, like that's okay. I just want to know so I can like skip, I guess. Well, there's only one question left, so I guess it doesn't matter that much. Yeah, awesome. That's good because this question like wasn't as easy as like some of the other ones have been. You guys all got it right, which is like awesome. I'm really glad to see that. Yeah. So this if statement is if C1 is equal equal. We can use the equals equals. Why? Why can we use equals equals for these? Right? Yeah. Exactly. It's a chart. Yes. Awesome. Right. It's a primitive data type. Exactly. Someone said it exactly right. It's not like a more complex object. It's just primitive. And with all primitives, you can use equals equals. And that's the only cases in Java when you can't. So that's great. And character.to uppercase A, right? And so you have basically A equal to, well, A, which it is. So you print, is it 1? C2 is not greater than C3 because we just look at the values, the ASCII values of C and E. And C comes before E, So clearly, I mean, C2 is less than C3. So it's not this. So we go into the else and we print it. We print this, 411. Yeah, awesome job. Cool. So, yeah, final question. Everyone ready? All right. Yeah, cool. Good job. We'll get to the results in a second. But in the meantime, let's go over this really quickly. Oh, yes, sorry. Moo. No one's making funny. No one's rooting against you. Everyone wants to see everyone else do well, right? I hope. No, I don't know. But yeah, I want to see everyone do well. Yeah, so this one, it's for an I equals 0, I less than name.length, I plus plus. So we're going through and we're checking every character, right? Basically what this program does, sometimes it's easier to like think about what it does in like English, for me at least. Like what does it do? It goes through every character in name, and if it's a space, it jumps back to the start. But if it's a period, it breaks, so it doesn't do anything else. And if neither of those two happen, it just adds the characters. So what that means is that if it sees, so let's just follow that pattern. Let's just, yeah, go with that. So you see the first character, it's not a space, it's not a period. So we add A. Well, the next one also, same. The next one is a space. What did I say about spaces? Well, we continue. So we don't do anything, basically, we just skip that character. Okay, so then we go to the next one. E is, well, not a space and not a period. So we do this. But now we see a period, and so we break. So we just print. And that's how we get AL. Cool? Yes, absolutely. Okay, I can go over them a little more in a few minutes right after we finish this. But like, absolutely, definitely need to know like substring, index of, char at, like those three, like for sure. And I'll go over them. But yes, yeah, like don't worry about it. Well, I'll go over them. So let's see who won. Good job, Hayden. Good job, Hendrik. Hey, Mujin, nice job. Way to go. And runners up. Nice. Everyone did great. Let's see, can I see the full standings? I don't know. Yeah, so that was really good. So really great job, guys. Okay, well, since I'm here, what I think I'll do is I'll just stop sharing for a second, and then I'll share just like a whiteboard so I can just go over some things really quickly. How do I do this? Yeah. Okay. So like the string methods you guys might need to know, I'll just go over them. So if you guys know them, that's great. If not, that's okay. These I'll go over them now. So the main ones are probably going to be like char at, index of, contains, I'm not sure. Yeah, I think contains is a thing. I think it's, but like that one's not as big of a deal. But yeah, contains is just like you give it a string, and if it contains it, then you do it. But generally, like these are probably the main ones you're going to need to worry about. Index of, and substring. Right, exactly. That's what I was just thinking as well, Hayden. You're completely right about that. And substring. So here's how they work. So char at, you pass it a character, or no, sorry, you pass it an integer, and you have to pass it something that's like less than the length and greater than or equal to 0, and it will give you the character at that position. So char at 0, if I'm using the string hello, I'm going to use it for all these, right? Hello. If I say char at 0, that's going to give me h. Okay. If I do char at like 100, I think, yeah, it's going to give me an error because there is no character at 100, right? So yeah, I can't do char at 100. That's no good. Okay. Index of, right, out of bounds. Yeah. So if I do like, okay, so let's say this is like str, right? Str equals that. So I would do like str.char at. And then the same thing here, I do str.index of, and char at for a number. Yeah, right. Char at a number. So char at 0 will give me the ASCII value of the first element of the string because it's an H. So it's just going to give me the character H. So that's why I put it like not in double quotes, but single quotes, because that indicates it's a character in Java. So yeah, it'll give the actual character. And character in Java is also an integer just between 0 and 255 because that's all the ASCII values. Okay, and for index of, so this one is important for sure. Index of will give you where something exists in a string. So if I did like str.index of, and you can pass it a string or a character, doesn't matter. If I gave it like he, the string he, this would return 0 because the first time that he occurs in the string starts at position 0. Okay. If I did str.index of O, it would give me 4 because it occurs at index 4. Now, what if I did str.index of L? What would that give me? 2. Yeah, awesome job. Right, it would give me 2 because it gives me the first index of. There's also something like last index of, but index of you can use anyway. So yeah, index of here just gives me like L, and that's right, gives me the first instance of L, which is just in the 2 position, right? Now, if it doesn't find it, it returns -1. So if I did str.index of, let's say, hi, what's that going to return? I guess I kind of gave it away, but I still want to see someone answering, or some people answering, even if it's just myself. Okay, I'll answer it for myself. Oh, really? That's a good answer. Andrew? Yeah, so it doesn't quite give null because it's actually trying to find it. Right. So it looks for it, and if it doesn't find it in there, index of returns -1. So like hi here would return -1 for str.index of hi because it's not in there. Does that make sense? Is that cool? -1 if it's not in there. Otherwise, it's where it starts. So if I did like str.index of hello, it would also give me 0 because hello starts at 0. Okay. Now, probably the toughest one, in my opinion, is substring. But like, I know Okay, this is how I think about it. So what substring you do is it takes one or two parameters. You can always use two. So let's just put two. Let's just say we have str equals hello again, right? If I do str.substring 0, 1, what do you guys think that'll give me? Oh, yeah, I will definitely go over that. That's a great question, Keller. And I will totally go over that in just a second. But it's important to know substring before we do that question. Yeah, so yeah, so awesome. So I'm seeing some hydrogen and some helium. Okay, that's a joke, but okay. Yeah, no, right. So here's how substring works. You look in the first position, right? It's 0. So you're starting at position 0, and then the number of characters that you grab is the second number minus the first number. So 1 minus 0. So 1 minus 0 is 1, so you get 1 character starting at position 0. So you just get H. Okay? If I did substring 2, 3, for example, what would that give me? Right, yeah, it would give me L. Awesome. Okay, and if I did like 2, 4, what would that give me? Yeah, exactly, LL, because it starts here, and then it grabs 4 minus 2, which is 2 characters, so it gets LL. Okay? Yeah, so that's kind of how substring works. Okay, so someone asked a question of how would we go about finding the second instance of? So I think that's actually a really good question. So let me show you guys how I would go about it. Like you guys can also like write stuff in chat, but I will go ahead and share my screen and we're gonna write some code. Okay, so I can show you and you guys can think about it too. Okay, so new main. I forgot to name it, right? So class new main. Okay, so we have our main. So let's think about it. So I'm just gonna put a string in here. So string str equals, let's do hello. Now let's make a, this is just so we can test it, but let's make a method here. Public static second index of, and then we get string s. Okay, so does anyone have any ideas of how we would do this? Well, let's see. We can use index of, right? This is not coloring correctly, so I'm gonna go ahead and do this. New main 2. Yeah, there we go. Yeah, so right. We could do that. Actually, I think index of does have that. Okay, yes, Keller, that answer is awesome. That is great. Yeah, awesome. Yes, and Maya, also great. And yes, okay. So those answers are like awesome. I love it. Yes, very good. So right. Well, the first thing we want to do is one thing we could do anyway, we could find the first index of it, right? Because once we know what that is, we can look for everything beyond that. So we can look for the index of, oh, yes, we can look for it. So let's do like string A and string B. We want to find where B is in A. So if I want to find index of, right? And then after that, we find the first index of. Okay, so let's start by just finding the first index of. So int first index of equals a dot index of b. Okay, so in this case, like if we passed L into this, hello and L, well, this would give us 2, right? So, for example, yeah, you could do that, Hayden. I think that would be good. But let's try something else. Like that, yes, is completely fine. But I also want to like mix in something else that we learned. So if we just want to find the first index of, and we don't want to use any other arguments for index of, we know that in the part of the string that comes after index 2, that's the part we want to look at, right? So what we could do is we could do a equals a dot substring 2, right? I think, or well, it wouldn't be 2. It would be first index of right +1 comma a dot length. Okay, so what does this mean? Does this make sense? Kind of like what we're doing is we're saying, okay, if we have our string and our string is like hello, then what we do is we find the first index of, which is 2, and then we say that a is equal to the part of the string that comes after 2. So that would be whatever comes after position 2, which would give us LO, right? This question is probably a little more difficult than anything you would be asked to write on the exam, but I think it's still good to know because if you can know how to do this, then you should be mostly good on the exam, I hope. So I'm just going over this for now. But okay, does this part make sense? How this would work? And then I would just return. Well, okay. So actually up to now, is this confusing anyone? What I did here? No? Okay. All right, awesome. Well, notice that we basically all we did was we cut out everything that came before, and also like we basically just cut out like the first index, everything before and including the first index of that character or string. So now we know that the next index of is the second one. So if we wanted to do that, we could do now just return a dot index of e. So let's go ahead and test it. System.out.println second. Zero. Oh, yeah, that's my bad. Plus first index +1. Forgot that part. Oh, first index of, yeah. And I'll explain the reason for that in just a second. Okay, yeah, and it gives us 3, which is what we wanted. So, okay, and the reason why I had to add that is because I had to add, like, when I took the substring here, like it cut out the whole first part of the string, so it gave me the index of it in the new string. So I still had to add on the length of whatever I moved from my string, because that all came before it. So I could just basically, wherever I started, I could just add on to the final solution. Okay. Does this solution make sense to everyone? Like if not, like tell me and I will try and explain it a different way. It does? Okay, that's great. But like, yeah, like I'll just say it in case, because I still haven't heard from everyone, so I'm just gonna like give this example. So like for hello, what I do here is I set A to be the substring of the first element, first index of +1. So I found the first index was here. So what I did was I just cut out this part. And that's what this line here does. Because it gives me this. It gives me everything beyond the first index of. And then I just need to return where the next index of is. So that's at 0 of this string, but then also add the length of this one. Okay? Cool. So we still have to get through a little more, or I still want to get through a little more with you guys. So let's just go to the next thing, which is on slide 18. This is there are some questions we didn't quite go over. So let's do those. Whoopsies. In the exam review before, we didn't quite get to all of them. So let's just go ahead and do those now. Let's show. Okay. Yeah. So can you guys try and do this one? See what you get? Yeah, what are the errors here, basically? It is missing something. Very good. What else? Awesome. Yeah, that's completely right. You're 100% right about that. Yeah. And okay, that's what's wrong with it syntactically, but like, what is wrong with it logically now? Where we try and print out all divisors. It has to be on the left. Oh, to be alone on the left. So like, if we're just, you're right. Oh yeah, sorry. Yeah, I see what you're saying. Yeah, if it were just an equality sign, 100%. Yes, that's right. Right. Yes, the if statements need to be, if else statements need to be if in this case. Should it be some instead of I? Finding factors, not divisors. Factors are the same as divisors, but that's a good one. But like they're just the same. Yeah. Some instead of I. Right. Yeah. And actually, right. So one thing is like, okay, how would we find all the divisors of an integer? And then we can kind of see what's wrong with what happened here. Also, like, okay, one thing is, yes, Hayden, yes, okay, is I declared twice? Yes, Logan, that's another error. Very good find. Completely right. That's also something wrong with it. So very good. Hayden, should it be some mod? Yes, absolutely. Because that would give us all the divisors. This one only gives us if it's 2, 3, or 5. And that's it. We want to see all of them. So you're right. If we did sum divided by I, or sum mod I, it will give us all of them. Right. We don't even need all these if else. So we would just do like if sum mod I, and then we print I is a divisor of sum. Right? Because that's just checking every single integer and seeing if it divides sum. So yes, that is right. So I think that's all the errors. So you guys did really well there. That was great. Yeah, so these are just errors there. I guess didn't have the other errors, but like, great job. Okay. So we have like one other question after this, and then we have a couple of response questions to go over, which I think are really important. So like, yeah. Okay, so what about this one? What's the output? Okay, I see a couple answers. Does anyone else want to take a stab at it? All right, awesome. Yeah, so 180. Yeah, that's great. Very good. Because I know this is a lot of calculation, but right, you're passing in 18 here and 9 here. So what that means is this is 9 and this is 18. So then we just do 18 times 9 is 162. It's 9 times 9 times 2. Yeah, and then you add 18 to it, and that's 180. And then here we set that equal to res, like res is equal to that. Let me print res. So good job. And again, like if anything confuses anyone, it's fine. But other than that, we'll go to this is the last question before we go over some free response questions. Okay. So break the output of this one. So I'm seeing a few 18s. So why does everyone think it's 18? Any ideas? 11. Okay. 11. All right. All right. So yeah. Okay. So let's go over this really quickly. So num1 is 4, right? N1, N2 is 9, and N3 is 18. Okay. So then we make our function call and we pass these in, right? But no matter what happens in this, one thing to remember is that Java passes primitives and like integers, it passes integers by value, which means any change we make to those values inside of another method doesn't mean diddly squat. Yeah, it doesn't mean anything. Yeah. So like, right, exactly. Yeah, it makes the function call, but it returns this, but that's a different num3. This num3 is the one inside of main, and this one is in different scope. So we only are worried about main, the scope of main, when we're in main, so we just print this num3. So it's just 18. So this is kind of a trick question, so like remember to be on your toes. Okay, and I think yes, exactly, Zane. Yeah, it would be, that's right. Okay. So now I'm going to go ahead and go to the free response questions because we did all the rest of these questions in the Kahoot. But let's go ahead and do this. This one is really, 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 really important to know. So like, yeah. So I'll give you a few seconds and then you guys can try it out if you want. or we can write it. I guess we'll try. You can try it on your own, and then we can also like try writing it together, and we can talk about it. So like, anyone have any ideas? I'll let you read it though first. So yeah, does anyone have any ideas? All right. Well, I'm gonna add a new file here. Let's call it custom substring jump. Okay, I'm seeing some things in chat now. Trim. So yeah, these are good ideas, but like for these types of questions, generally you just have to use like whatever they tell you in the note, pretty much. So like you can't use that. You have to use like char at and length. Okay, I'm seeing some good answers. Yeah. Awesome. So let's try it out. So class custom substring. I'll just make a main. Right. And then we can also go ahead and make our function now. Okay. We're going to call it public string substring string s. So I saw some people saying that it would be a good idea to go ahead and use a for loop. And that makes sense to me, right? Because a string has a certain length, right? And so we want to start at the begin index and end at the end index, right? So, okay, like let's look at a quick example, like hello. I don't know, going back to this example again, sorry. But yeah, it's a good example, I guess. So here, if we wanted to get the substring 0, 2, just like the regular substring, we would start at position 0, which is begin index, and we would go up to end index. And we would get 2 characters, right? So we could do, like we're going up to end index minus 1. So one way we could think about going about this, right, is by going up to like, do we want to include the second index is what I'm saying, I guess, in this case? Do we want to include L? No, right. So how would we, like, if we were to use a for loop, how would we make sure that we don't include L? You know what, let's start writing it and then we can see. But if anyone has any idea, you can send it also. Well, we want a for loop, right? We want to go ahead and start at the begin index and go up to the end index. We start at the begin index. We end, if we do like this, end at the end index. That's what this is doing, right? And then we can do, well, what do we want to do? How do we get the next thing from our string? Just use less than. Okay, that's a good point. But why would we only need to use less than? It says up to go up to index, right? Right, yeah, we only want to use less than. Yeah, okay, very good. Because if we use less than or equal to, it'll get the second character as well, right? So if we only want to get the 0 and 1 characters, we would only do less than, because that way we're only getting 0 and the 1 for 0, 2. That's why we get the difference, and that's why we're making sure we're not including 2. So very good catch. Yes, awesome. Yeah, that's a great idea. Okay. Yeah, so we can do like string temp equals just like empty, right? And then what do we want to do inside of the loop? Anyone have any ideas of how to add to the string? Yeah, that's great. That's right. We want to add the next character, and the next character is at position I. So we do that. We would do like temp equals temp plus s dot char at I. And then what do we do at the end? Return temp. Exactly. We need to return a string because that's in the method signatures. We need to return a string. And the string we created is exactly the string we wanted. So we need to return temp. Awesome. So if we want to test it really quickly, let's just do like string s is equal to hello. And we want to do call substring. So let's do system.out.println s dot, oh no, substring s, and let's do like 2,5. And yeah, let's just see how this goes. Let's do Java C, custom. Oh no. Oh, I didn't make it static. Awesome, yeah, it gave us the second, it gave us 5 minus 2, which is 3 characters, right? And it started at position 2, so LLO, which is exactly what we wanted. So does this solution make sense to everyone? How we got this? Can you use concat? Yes, if you want to concatenate something to a string, you can. Instead of plus, yeah, you can do that. I suggest plus just because it's easier or it's faster to type. So like on an exam or something, it's just maybe easier. But if you prefer concat, that's perfectly okay. Yep. So this is how we wrote substring, and you guys can totally ask a question if you have one. Sure, I can totally explain the loop. Yeah. So what we wanted to do is we wanted to get every character in string S starting at begin index and ending at end index. So what that means is that we would want to like start at begin index, right? And then get every character and keep getting every character until we get to end index. Well, that sounds a lot like a loop, right? Okay, and I'll get to your question in a second, Mujin. I hope I'm pronouncing your name right. Sorry. Yeah, so we want a loop. And so we start at begin, and then we go up to end, right? So I equals begin, and then I less than end. Awesome, yeah. And then we keep going, right? So this is going to get us every single character because we only increment by 1 each time. And then while we're inside the loop, well, char at I gives us the character at position I. So what that means is that char at begin index is like the first one we're going to get is char at I starts at begin index. So we're going to get char at begin index, then we're going to get char at begin index plus 1, all the way up until we get to end index, right? So we're basically going to get all of the characters in the string starting at begin index and up to end index minus 1. And we just keep adding them to temp. And then we return temp. Yeah, Keller, that's exactly right. So without braces, it just like an if else only does like whatever comes directly after it. Although like else's still apply. So right. So like if I do like if x equals 5, do this like print x or something, I can still put like else. And it's almost like you only have braces around that one line. So Keller, you got it exactly right. Okay. And also, I know that's center, but I hope that makes sense, Zane. Yeah, chart outputs one character. Right. That's exactly right. Yes. Okay, kind of. Okay, yeah. So like you said, yeah, we just get one character each time, and that character's in position I. Oh, okay, well, cool. Okay, good. All right, because we have a couple other questions, so we can get to them. But also I want to make sure I have time for this because like you guys can go over questions in your own time, worst case, like, but like if there's anything that like you guys don't understand, like now I guess would be a good time to go over that. And I'll also want to make time for some more free response questions, so I'll try to get to them, but I want to make sure I make time for questions you guys have. So do you guys have any questions about like anything at all, basically? Okay, yeah, that's a good question. I like that. How is the free response question going to work on the exam? So you get a text box, right? And then you just write your code in there. So you're usually going to have to like write one method or something. So they give you specifications. So it's going to be like similar in a sense to how this question is, where it gives you the question, it tells you like, oh, this is kind of like this is the header, the signature of the method, right? And then it tells you the specifications of what you're allowed to do, what you're not allowed to do, what it has to return. And then you write it in the text box. I'm not expecting perfect syntax, and I won't take off for like syntax problems unless it's like really, really bad and like you're making things up. But like generally, I won't take off points for syntax. And then, yeah, there's no way to run it, unfortunately. But like it'll be questions like no, for the most part, no worse than this. Yeah, I'll explain the math for the last lab in a second. That's a good question as well. But for this one, yeah. Sorry, some other teams are messaging me. Yeah, okay. So, sorry, I lost my train of thought for a second. Yeah, so the questions on the exam are going to be like generally no worse than this. You won't have a way to test it, but like as long as I see that like you're able to like think it through and start on the right track, I'll give you some credit. There's partial credit on it, so even if you don't know it, make sure you put something, because if you put nothing, I can't give you any points, but if you put something, I can give you points. And like, yeah, it's something like you won't be able to test it, unfortunately, but like you can kind of think through it, kind of like we were doing a minute ago here. And as long as you're on the right track, you'll do well, I hope. Okay, so the math for the last lab, converting numbers to different bases. Sure. So that would be like, do you mean like if it's like 1F, 3, A, C or something like that, and you want to convert that to base 10? Is that what you mean? Because like I feel bad. Like I that was something I probably should have gone over last week. So I'll go over it, but I wasn't here. So I'll go over that now. That's a good thing to do. Yeah. So like, I have my presentation actually that I created. So let me bring that up. Oh, okay. Oh, sure. Okay. Then yeah, I guess my presentation won't help that much. But let's talk about it then. Like we have 1F3A, right? So in this case, what we want to do is, right, we have 16 to the 0 times A, which is 10, right? Plus 3 times 16 to the 1, and so on, right? And this is how we would go from hex to decimal on paper. But this isn't paper if we're writing code. So what we have to do is we have to get the character, the last character in the string, So we can like get like use char at or something, right? Char at length -1, length -2, and so on, all the way down to 0. So we get the char at that, and then we can convert a. That's what the hex char decode method was for, by the way, in the lab, was to convert all letters into their respective numbers. So if you're passed a string, it turns like those characters into the correct characters. So like if you're passed in A, it'll turn like A into 10. That's the hex char decode method is for. So you get the character at like I, right? And then you turn that, you call the hex char decode method. And so that, for example, with A would turn it into 10. And then we multiply it by the respective power of 16. So in this case, 16 to the 0. And then we do the same thing with the next character. So we go back a character and increment 16 to the power of the next power. Do you see where I'm going with that or not? Because I know that's tricky. And like, method that does it. Yeah, so like you're not really supposed to use the integer method. But yeah, this is how you'd go about it. Is like, right, you have like, for example, like I don't know, 3C or whatever, right? So you get the character at, you can get the character at 0, and that's the one with 16 to the 2. And the one at position 1 will be 16 to the 1 in this case. And so it's like one goes in reverse order of the other. But you're just changing each character and incrementing the powers. That's the lab. And yeah, so I guess because this is an exam review, the main thing, I mean, you can totally ask me about that too, but for an exam, like there isn't enough time or testing to like ask you to do anything like that probably. So it's important to know how to do the math by hand, I guess. Like, yeah, and if you know how to do that, then you should be good at least for the exam. Okay, are there any just other general questions about like preparing for the exam or anything? Because if not, like there are more for response questions I wanted to get to. But if so, I can try and do both. Either way, okay, I guess I'll go to the next. Okay, yeah, actually, let's look at this. Although, yeah, if you have questions, like ask them while I'm going over this too. So it looks like our answer was exactly right. Here's what we were looking for. So awesome job. Okay. Oh, yeah, this question, like for sure. I definitely wanted to go over this as well with you guys. Yeah. And I'm not gonna make a new file, I'm just gonna put it in here. I'm just gonna write this. So, all right. Let's see this question. So again, if you guys have questions about something else you want to know about, ask. But like also this question here, go ahead and read it and then tell me if you have any ideas. Modulo 11. Yeah, that's a good idea. That's a really good idea, actually. Nice. Because if they have the same digits, it must be divided by 11. I like that. Very good. Okay. Well, let's go ahead and like try and write some code for it, okay? Does anyone have any ideas of any other ways to do it also, or anything else about this question? Yes, we could, if we interpret it as a string, for sure. We take it as an integer, so we'd have to find a way to turn that integer into a string. There's a way to do that. But yes, that is totally another option. And you can also get the, like, strip the characters off of the number as integers. But like that includes like a loop and like division and all that. So like, but that is like totally also an option. Right. Integer, yeah, integer.toString num. Yes, that would be the way to turn it into a string. Okay. Well, you know what? Since two people said two different answers, let's go ahead and try them both. So we need a loop, right? It said in the question we need a loop. So let's go ahead and make our loop, right? What do we want to loop from and to? Okay, for it, I equals 0, right? Do we want to do 0? I less than what? We could do 10, yeah. Nice. A while loop would probably be easier here. You're completely right. So let's do that. Well, what's our starting point? Where do we start? 10. Okay, let's read the question really carefully. It's in the range 10 to 90, but it takes in an integer num, and it prints count up starting from, yeah, the parameter. Nice. So in start is num. So we'll go with, I think Keller, you said your idea first. So let's go ahead and try that. Yeah. So, okay, we can make a while loop, right? While what you want to do? Awesome. Yeah, great. So I'll write that exact code. Yeah, not num modulo 11 equals 0. Yep, perfect. Well, it's not basically while number is not divisible by 11. What do we do? Anyone know? Who else is here? Hendrik, Hayden, John, Karthik, John, Maya, Mujan, Zane, Andrew. Okay, Andrew's me. So anyone else have any ideas besides me? System that out num plus plus. Yes, we could totally do that. Well, I think that is a good idea, but I'm just going to put it on two separate lines so it's like less confusing, at least from my point of view. Like this looks like it just reads a little bit better because we print it and then we increment it. And while yours does that all in one line, and that's awesome, this just reads it more easily for me. But yes, awesome. Okay, does that finish this? Like if we were to just print this, would that be everything? Well, I guess first we have to print output, right? So I'll do that. But is that everything? Okay, yeah, num plus zero. Okay, one thing that I wanted to say, or that I think like, because you guys don't have a way of like just testing your code on the exam, one thing that I think is really, really, really helpful for understanding your code, and like how I often like go through when I read your guys' code, if like there's something that's wrong, like in office hours or something, is like try different inputs and see what works. Like in your head or on paper or whatever. Just like test it. Because you can test it without the computer. You can test it by hand. So let's do just that. Let's run these test cases by hand. So if num is 18, let's plug in 18. 18, we start at num. We print output, perfect. While num is not divisible by 11, we print num. So we print 18, and then we increment num. We print 19, we increment num. 20, 21, and then we increment num, and now num is 22. But 22 is divisible by 11, so we exit the while loop, and we never printed 22. We could put a break. Yeah, that's the. We could put a break, but this while loop, you don't need a break for a while loop necessarily, as long as the condition eventually is met. That's okay. Yeah. So, but it seems like we're missing the 22, and let's try the example of 66. Well, with 66, we pass it in. We start at 66. Well, 66 is not divisible by 11, which it is, so we don't even do the while loop. So what can we possibly do? Subtract 1 and increment before. That's an option, I think. But I think we're gonna run into the same problem eventually. No, we wouldn't. You're right. You're right. But from my point of view, there's something slightly easier than that. That solution, yes, will work. But I got it. Exactly that. Yes, just put the print statement outside the loop. Because we're only missing 1, right? So let's just print them. Because we incremented it the last time, we just didn't print it for the very last time when it was finally divisible by 11. So we can just put the print statement outside. Exactly. Yep. And let's just go ahead and do the one that Maya came up with really quickly. Void. Actually, I'll just. It can't be exactly the same, but like it can be similar. There we go. And we can do the integer.toString, right? So string s equals integer.toString num. Well, we would want the same thing as before, right? We'd want a loop. So while that condition is not true, right? So we can do like, for example, I'm going to speed through because we already did this question once, so I'm just going to do like similar thing. Basically, while true, if, okay, string s is that, if num dot substring 0, 1, or num dot, sorry, char at 0 equals num dot char at 1, then and then otherwise we just always want to just print it, right? So we would just print out. So all this solution is doing is kind of like taking both things together. So like we just keep looping. We keep going to the next character or next number. Oh yeah, and num plus plus. We keep going to the next number until we hit this point where the two characters are exactly the same and we break. But this other one, this other solution, we keep checking if it's divisible by 11, because if it is, because it's only between 10 and 99, or 10 and 90, then like, if it's divisible by 11, then that's when the two digits are the same. So like, I'm just gonna keep going because we don't have a ton of time left, but like, so I'm not gonna go ahead and run the test for it, but like, this is the code that would work, and we can look at what the solution is, but do these make sense, basically? Oh, yeah. So Zane, so the problem is that when we didn't have this, it didn't print out the last one. So like if we put in 66, for example, yeah. So both these solutions are like very similar, but for this one, if we put in 66 and didn't have the print statement at the end, it would keep going while num is not divisible by 11, right? Well, if num is not divisible by 11, then we do this. But if we pass in 66, for example, well, 66 is divisible by 11, so we never go inside of this while loop, so we never print anything at all. And even with 22, or even with like 20, when we go with 20, it's going to print 20, and it's going to print 21, and it's going to go back to the top, and it's going to go to 22, and it's going to say, oh, it's divisible by 11. So we don't do this. And then it never prints the 22. So the problem was is the code before just was missing printing when the digits were identical. And so like on an exam, something that's really, really good to do is like read your code over with different examples and see if it actually does what you think it does. And like in this case, we all forgot something, and that's okay as long as we manage to catch it later. But does that answer why that was, Zane? Like, awesome. Okay, is the break during the same? Yes, 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 exactly. It's the same as setting the true to false. Generally, I don't really like using break, but like here it made sense, so I did. But whatever. Yeah. But yes, that's exactly what break does. Break just like exits the loop. So it's the same as setting true to false. Except it also doesn't like do whatever comes after. Like it just ends the loop right there. Okay. Yeah. So this was the other way of going about it. Yeah. So this was what I was saying, where you could like strip off the digits by dividing and using modulo. And like this would be the other way of doing it. Like instead of using a string, they used integer, or they just used like math to check if the digits were the same. But like it's basically the idea we went with for strings, except just with integers. So we had these solutions, which were totally good, and these solutions are also totally good. Okay. All right, we have two more. So I'm gonna sort of speed through them, unless you guys have like questions about anything else. But otherwise, let's see how this one goes. Let's go ahead and write this one. Okay. I'm just gonna write the signature, and you guys can think about how to do the problem in the meantime. And let me know if you have any ideas. Okay. A nested for loop. Nice. Okay. So what would be the outer for loop? What would be the inner for loop if we were to do that? Like what would be the upper bounds of each, I guess? Mm-hmm. Yeah, that's right. Okay, let's do that. So the first thing we want to do is, well, I guess we want to start with 1, right? Because we want to make sure that the very first level, we have at least one of those things, right? We could do 0, but let's just do 1, just for the sake of like a little bit easier to read, I think. But yeah, oh, okay. Oh, you had 1. So yeah, that is awesome. Yes. Right. So I is 1, I is less than or equal to the base, right? And that's like the outer one is how many levels we're going to have. And we have, well, this many levels, right? We have base number of levels and I++. But for each level, we like this is for all the levels. Kind of like how in blackjack game we had all the games, and then each in the inner while loop we had that particular game. Here we have all the star rows, and then here we want to do the star columns. So like for each particular row, we want to increment by 1 each time, right? But notice, for each row, we're already incrementing I by 1. So we can just do int j equals I, j, j equals, well, we could do like base, yeah, minus I, minus 1. Okay, that's starting to get messy. So, I mean, it's right, but like, yeah. Or actually, alternatively, what Keller said was a lot better, a lot easier to read. I like that. Awesome. J is 1. Or let's just do, yeah, 1. J less than or equal to I, J plus plus. And that is a great idea. We go from 1 up to I, and then we just print that, and we can't forget to make sure it goes to a new line. So what we have to do here is then in the outer for loop, but not in the inner for loop, we have to go next line. Yep. So let's think about what this is doing really quickly. All right. So just for readability here. All right. So we start at 1, right? I equals 1. And we go up to the base, where base is, let's say, I don't know, some number. And then in the inner for loop, and that's the number of rows we're going to go through, because that's the number of times we print ln. And then for each particular row, we just keep printing stars. And we print it from j equals 1 all the way up to I times. So if we try an example like 5, then it's going to print, it's going to go I is 1, I is less than or equal to base. So it's going to print 5 lines. The first line, it's going to do j equals 1, j less than or equal to I. It's going to print 1, and then it's going to go print next line. Next time it's going to print 2, and then 3, and so on, until it gets to 5, which is exactly what we wanted, right? Yeah. So does that kind of make sense? Like, I know that's kind of tricky. I want to see. Okay. Yeah. Is that one good? Or not so much? Not so much, or it's good? Sorry, I don't know which one I was referring to. Oh, good. Oh, that's awesome. Okay. Glad to hear it. Yay. And also, yeah, great job, Keller. That was a good solution. And I know that question is tricky, so if you didn't get it right away, that is perfectly okay. But like, it's good to know like how to kind of do these questions, like for example, whatever. Yeah. Okay. So now we have one more. And it looks really similar to the previous one, except it's inverse triangle. So any ideas on how to do this one? And actually, wait, anyone who answered like previous free response questions, like don't answer this one. I want to see, I want everyone to be included, I guess. Yeah. So knowing what we used from the previous one, how do you think we can go about this one? And if you don't know, like that's okay. This is like it's bonus for a reason. This one is like genuinely pretty tough. Well, okay. The first thing is like this question has some similarities to the previous question, right? I think we can all kind of agree on that, right? So I'll make the method signature first, and then we can see. And I know we can't go too much longer, so I'm gonna, yeah. No. So now, well, let's think. Before, what's the difference between this one and the previous one? Like, what's the difference? And are there similarities? Okay. Can anyone tell me any similarities or differences between this question? And yeah, I guess anyone can answer this, even if you already answered the question. Oh, yeah. Awesome. Yeah. I can be decreasing in the previous loop. So let's see. We start at base, right? And then we go all the way down to 1. Yeah. Then that would totally be an awesome answer. Yes. That is amazing. Yes. Okay. So let's talk about why that's a good answer. So I will just, well, instead of copying it, let's just go through it. But yes, awesome. Awesome, awesome, awesome. Great job, Ender. So yeah, for int I equals base, right? I greater than or equal to 1. I minus minus. Now we're going the opposite direction. We're starting at base, we're going down to 1, and we're decreasing each time. Because, well, all we want is our outer for loop. We still want to make the same number of, oops. No, that's not it. Oopsies. Oh yeah, custom substring, there we go. Yeah, we want to make the same number of iterations as before. We still want to go through base number of levels, right? So we're doing the same thing here. We're still going through 1, 2, 3, 4, 5, all the way up to base, except now it's in the opposite direction. Now that means in the inner loop, we want to print more stars at the beginning. So we can still go up to base, right? We want to start with, the first time we want to go from 1 up to base. The next time we want to go up from 1 up to base minus 1. And then the next time from 1 up to base minus 2, right? But that's exactly what the value of I is. So we do this, j equals 1, j less than or equal to I, j plus plus, and it ends up being the same thing. So it's just the only thing we had to change. Yeah, the only thing we had to change was that we had to go backwards in the first loop, because instead of because it changed what j was doing. Instead of j going up to like wherever I was before, or instead of j increasing each time, now it's decreasing because there's fewer and fewer elements that j has to go up to. So actually, you know what? Let's go ahead and run these programs. Let's run all of them. Why not? What do we have to lose? Print on identical digits. Oh no, I just want to call it identical digits. On num. So let's say num is 52. And then I want to do the same thing with the other one. Yeah, sorry, I know we're going a little bit over, but I'm almost done here. And then the last one is, and if you do have to go, it's okay, but yeah, let's try and get through it. Let's say 5 and print. Okay, now let's try running it. Let's make sure we didn't have any errors anywhere in our code, because it's possible. It's likely. That's okay. Oh, 5 errors. Nice. Okay. Yeah. Num.char at. Ooh, yeah, that was my bad. I meant to do s equals s.char. Yeah. Okay. Oh, Did I have to declare? Yep, forgot to declare it. Okay. See, like syntax errors like that, I'm not going to take off points for, because like if you don't have a compiler, yeah, it's not your fault. Okay. Or you don't have a compiler or anything like an IDE, I won't take off points. Ooh, good catch. You're right. I wanted to test both. So awesome. Yeah, it actually looks like it's doing the right thing here. Our custom substring works. This one, it's all in one line, but that's okay. It goes up to 55 and prints it. This one goes up to 44 and prints it. And this one, I mean, the star starts on the wrong line, but as you can see, it goes all the way down to 5, and this one starts at 5 and goes down to 1. So that's all the methods. That's all the free response questions that we had to go over. And as you can see, like this solution is like pretty much exactly what we had. So awesome job. Yeah. So these are the kind of like the kinds of problems you want to know how to do for your exam. So if you know how to do these, you're set, or you're in good shape anyway. And if you don't, that's okay. We can talk about them. So like I know class is over. So like if you want to go or if you have to go, you can. But if you want to stick around, if you have questions about any of this, or questions about anything on like about the exam or like anything, like stick around and I'll just answer questions from here on out. Okay, so go for it. Yeah, I'll stick around until everyone leaves. I don't care how long that is. So just go for it. Yeah, no problem. And I'll keep recording it, but like questions about anything here or anything on the exam, anything? Oh, bye. Okay, yeah, bye. Zane, John, Karthik, you guys got any questions? Or you can leave if you need to. Oh, yeah, sure. So I know that one is definitely tricky. So we can totally go over that. Right. The nested loops of a triangle, like these questions are meant to be a little bit trickier than some of the other ones. Yeah, right. Getting the general idea and actually being able to program it, I know, are like completely two different things. And like it can be difficult. So like let's think for a second. What we're doing in this one, in the print triangle one, is we want to print base number of lines, right? Okay, so that's our first step. We know we want base number of lines, and base is some variable. So we're going to want a loop for that, right? And then, okay, so that's how we get that knowledge. We know we have to have a loop to print like each of the lines. And then for each line, we want to print one extra star. So that's kind of tricky, but the first time we know we want 1. Second time we know we want 2. Third time we know we want 3. Oh, yeah, it's probably easier if I draw it. Like the inspiration for having nested for loops was because we had whatever base was, we needed that many lines of stars, right? And so on. And then, so that's what this came from, is we know we need base number of rows, right? But then for each row, we want an additional star. So the first row, we only want 1 star. Second row, we want 2 stars. And the third row, we want 3 stars, and so on. So there are a couple ways of doing this. Like the thing is that we know that on the first row, we want 1 star. On the second row, we want 2 stars. On the third row, we want 3 stars. Well, the row number is equal to I, right? I is our row number. And that's also the number of stars we want. So we just need a loop on the inner loop just needs to go through however many stars, whatever row we're on, because whatever row we're on is how many stars we're going to print out. And so that's how we get this inner loop. Like we just print from 1 up to the row number. And that's how many we're printing, is basically whatever row number we're on is how many stars we're printing on that row. And if we want to actually check that by hand, we can like trace our code. Be like, oh, if base is 1, for example, we print 1 star. If base is 2, we go I equals 1, I less than or equal to 2, and we can like go through the code and we'll see that but okay. Is that still a little confusing? Like it probably is still a little confusing, and that's okay. Yeah, that's okay. I'll try and explain a little different. For j less than or equal to I, don't I and j both equal? Yes, they do. That's completely right. And that's okay. Because what happens is that, right, we're incrementing them. So like, here's how I like thinking about it anyway. Like basically, it's 2 separate things. So the outer loop is just like, how many different rows do we have to print, right? Like basically the outer one is like, we print this many rows, right? And then when we're on the ith row, we want j stars, right? Or when we're on the ith row, we want I number of stars, right? That part makes sense, I hope. Yeah, okay, cool. So then, basically, if I just comment all this out, we know we want I stars when we're on any row. Well, when we're on the ith row, that means that for any I, we want to print out j stars, right? So, okay, you know what we could do, something that might make it a little easier to like kind of understand is what happens when we another method. So just like print I stars. Let me just pass in I. Where print I stars, I hope this doesn't make it more difficult to read, but we'll see. Print I stars in I. Well, if we want to print out I stars, then what do we have to do? Well, we can loop, right? For it, well, we can do just like j equals 0, or j equals 1, for example, j less than or equal to I, j plus plus. We're just making some loop that's going from like 1 up to I, and we just want to print a star out that many times. So this is just a loop that's like every time we go through, we're just printing a star. So we're printing I number of stars. That's what this does. So like here in this loop, we're just saying, oh, okay, for each row, print another, or print I stars. Yeah, exactly. Okay, awesome. Yeah, that totally makes sense to me. Both I and j increase at the same time, but right, I stops when it reaches the length of the base. Yes, it does. That's exactly right. But the thing is that j, like the inner loop, when we have nested loops, the inner loop runs even when, like, the inner loop runs all the way through inside of the outer loop. Like, if we have these loops here, j goes all the way until it hits I, like all the way through. And then when it finally does, let me go back up to I, like this outer loop, and print a new line. So we basically we do all of this, and this is only for one line, is for this for loop. And then we wanted, how many times do we want to print a new line? I times. So you can also think of it the other way if you want, if it makes it easier. If we want to print a certain number of stars, we do that here, and then we just do that I times. Right, yeah. The inner loop doesn't do just one iteration. The inner loop, whenever you have nested loops, the inner loop does an iteration every single time that you enter the outer loop. Right, every time. Every time it completes, you start again with the outer one. So like the inner one will go base number of times, basically. Yeah, and for the other question, like the other one, it's a similar reasoning, except you just want to like go backwards because you want. Yeah. Oh, cool, that's great. Yeah. Okay. Are there any other topic? I mean, even if you have any other questions on this, or are there any other topics you're wondering about? Okay, yeah, no problem. Good luck on the exam. Have a nice day.